A person with a weight of 500 newtons climbs stairs to a height of 3 meters above the ground. What is the gravitational energy of the person at this new height? And if we're going to let the ground be where h is equal to 0. So our person is going to climb these stairs, and when our person gets to the highest step there, it'll be 3 meters above the ground. So let's find the gravitational energy of the person at this new height. So remember, gravitational energy is mgh. We always use standard units for physics problems. That means we're going to use meters, kilograms, and seconds, MKS. So we need to make sure that our mass is in kilograms and our height is in meters. Our gravitational constant will be about 10, but remember it's in meters per second squared, and so it follows the MKS rule. So that means that our unit for energy would be kilograms times meters over seconds squared times meters. So I just multiplied all three of these units, and that gives me kilograms meters squared, because we have a meter times a meter, over second squared. This is known as a joule, named for James Prescott Joule. We use the letter J as a abbreviation for joule. So let's determine the gravitational energy of this person. Now note, this question, we have the weight of the person. Now remember, weight is mass times the gravitational constant. So mg, and look in our energy equation, it's mg times h. So we will just solve for our gravitational energy. Mg will be the whole 500 newtons, because m times g is the weight. And then we'll multiply it by the height, which is 3. So 1,500 joules is our gravitational energy stored in the position of the person at this new height. So we have a 10-gram marble with a speed of 20 meters per second. What's the kinetic energy of the marble? So kinetic energy is 1/2 mass times velocity squared. Now let's look at the units for this. Mass will be in kilograms. Remember, in physics we have everything in meters, kilograms, and seconds, MKS. So our mass should be measured in kilograms. Our velocity will be in meters per second, but we're going to square it. So the unit would be meters per second squared. And then that gives us a unit of kilogram meters squared per second squared. That is the same thing as a Newton times a meter, and we call this unit a joule, or J for short. So we need to make sure that all of our units are in kilograms and meters per second. So when we look at our problem here, we have a 10-gram marble and 20 meters per second. So it looks like our mass needs to be converted, but our velocity or our speed is in the correct unit. So a 10-gram marble is the same as a 0.010 kilogram marble. Remember, there are 1,000 grams in 1 kilogram. So I'm using the conversion, 10 grams, doing dimensional analysis here. 1 kilogram there. The gram and the gram cancel out. So then I'm left with just 10 divided by 1,000, which is 1/100th, which is 0.01, and that will be in kilograms. So that is just a conversion. So once I have my mass in the right unit, I'm ready to substitute. So substituting in the mass of 0.01 kilograms and our velocity of 20 meters per second, and don't forget to square it. And then our answer would be 2 joules.